this is Tech 163. There are cubic area over here. Everybody knows that cubic area, right? This is my room. This is 163, 164. This is cubic area. So I'm going to see your program. You will demonstrate for 1 cubic for each team. So you can set up the one available seat, then should be ready before the time. Then show me the first log on, then the minimum requirement, which means first log on, then select the table, select the column, and select the operand, select the condition, then show me the result. That is the basic thing. Then if I have a question about yours, for example, why don't you log on your database using the SQL Plus? So it's a good idea. First, you log on the SQL Plus, then be ready to type any SQL. Okay? So, and also sometimes I can ask her to open your source code to see how you implement. Okay? So sometimes I can quickly skip to other team. That doesn't mean your program is worse. Sometimes it's good news because it looks like the perfect, so I don't have to see all details about you. If just in case have the problem, if there's available time between the team, I can take a look at yours. Otherwise, it will be you should wait until me or the GA are available. You understand what I'm saying? So this, the cubic area will be used for demonstration. So I'm going to moving around each cubic by cubic, then we'll see your program. This is not the mandatory, but I strongly suggest you to demonstrate. Okay? Yes?
We have to demo by the laptop, by the computer at the
then,
lab.
So some of the students need to use the computer at the time. You can use one of the computer in 163, let me know. Okay, so your program is ready in one of the computer.
We
okay?
can use our laptop.
So if you are using the laptop, you can take a seat, one of the available cubic area. Then I will call the who is the next, then we'll demonstrate. Then we can save a time. I know some of the students need to attend some prayer time, 1 o'clock, right? So I try to do my best to finish before that time. Okay? Any other question for the demonstration? Okay, so and also the GA and me will not see or check all your programs together. Sometimes he will do the other team if we are in a hurry. Okay, so don't be afraid or don't be frustrated. Professor Lee don't see anything about my program. Okay. Next week we are going to have the exercise. Actually, there's a schedule for both Tuesday and Thursday, but I'm going to have a lecture on Tuesday. Then we will have the last exercise lab on Thursday only. So do not go to the lab 163 on Tuesday. Tuesday we will have a lecture over here. Then the Thursday we will have the exercise lab. So we divide into two already. So please take a seat as assigned the time slot. Come on. It's almost the end of the semester. I'm surprised this morning. So next week is the last week already. So let me quickly review what we have learned so far. So first of the semester, we did about the database design, right? So what is a database design? Database what?
By scheme.
Schema. So eventually we'd like to make the database schema. What is the database schema, by the way? Yes, a data structure, right? It's a structure. Who answered? I don't give the extra point. So, yeah, it's a description of the data, but there are a bunch of different way of description about the data, right? So, for example, you are using C program. In C program, without data, there's no way to process something number. Number is the data, and sometimes you can get the data from the input, sometimes you can get the data from the random function, whatever. All of them are data. It's the same data as we are dealing in this class. The different thing is, in case we have very large data to be managed using the computer, we need to have the different data structure. That is the database design. The problem when we manage the data using the database, computer cannot understand what we are asking. Please make the file of this one. Why don't you sort by the student? And why don't you make the average score? You can do that. You can understand what I'm asking. You can manage the data. However, computer cannot understand such a thing. Instead, we need to make the data structure, which is the only way that computer understands. So, for that specific data structure, we have used relational database model. So we can start from something information which is not structured data. It's not structured everything, like the temperature of this room and the temperature of the next room, or the weather is fine, or the UV is very cold. Those are the information. However, we need to organize such an information, right? We need to organize, collect some information, then make the common thing. That is called conceptual modeling, high-level modeling. For example, one of the example of the output is like the ER modeling. So we can use ER modeling is one of the example, just example. We can use different modeling, like the UML modeling, object-oriented modeling, network modeling, and a bunch of different modeling. But among them, we actually learned about ER modeling. The entity is the thing. So common thing of the entity, like the student entity, student A, student B, student C. We collect all the student information, then realize there might be the common attribute, like the name, ID, address, major. So we will keep such information. That is the logical modeling, or conceptual modeling, or high-level modeling. So far, we don't need any computer science, computer engineering skill. It can be used for anything, even in your house work. So you can organize some tool shed or your room. So at that time, you can use such a thing. I'm not sure whether you can use such a ER model. So that is the first thing that we have learned. However, still this is far from computer. Computer cannot understand such a diagram yet. We need to get close. So to address to bridge the gap, we learned about relational model. This is called relational database model, which is based on the concept of relation. Relation is the different name of what? It's a set. So we adapt the idea of set theory. Why don't we consider group of students? It's a group of students. We find the common thing, so we define the student entity. So why don't we consider that group of students as the one relation? In other words, it's a table. Okay? Then we can create something table using what? DBMS software. This is the software which is based on the relational model. Then eventually, finally, we can manage the data based on relational model using DBMS, especially relational database management system software. Okay? So that's the first thing we did up to the midterm exam. So 2/3 of the semester we spent the time to understand to then use such a database design. However, since we are using such a software, relational database management system, if we know about the DBMS software very well, we can utilize the benefit of the database management system a lot. So we try to understand what's going on inside the relational database management system. So first we learned about the file structure, right? How the file, in other words, how the table is organized. Can you remember this one? So three-schema architecture. Three-schema architecture is an ANSI standard. It's a standard. In other words, if you want to build a database management system, you can follow such a standard. So we focus in this database design, we focus on such a conceptual design. However, since we are using the software, we do better know the internal data structure. External data structure is nothing but the view in relational database model. So for the internal data structure, we have learned about the file structure as well as another thing, indexing structure. Indexing is a different concept from the other data structure. For example, you are using the Java. Java, in your program, you have the data management actually. You can manage the data using vector or some other list data structure. But do you have such an indexing? Some of the programs provide such a different data structure, mostly not. DBMS provide such a different, little bit weird data structure to manage the data. It's additional, but the reason why we consider such an additional data structure is speed up. Since we are dealing with very large data, it takes a long time to find the data, even though some of the file system, file structure provide fast way to access the data, like the primary. So you can order data file record by primary attribute. Then we can use binary search. Why? I'd like to access the student data by major, which is not organized by the major. So it takes a long time. How can we address such a thing? By indexing. So I probably mentioned them several times. Why do you use the database management system? Why? Why do we need? Management is one issue, but the more important thing is how fast you can access the data. That's the key point. So computer science guy, computer science student, computer science people are fighting every time, every second. How do we speed up to process the data? Right? Is there any algorithm that is decrease the performance? No. Every time we fighting with the performance, how to increase that performance, right? So same thing. Database in DBMS, we want very, very reliable. It's strong. There's no problem in terms of the backup and recovery or disaster. Yeah, that's fine. But if your database system is very, very slow, I don't think that's a good DBMS system. So that is a key issue, how to speed up to access the data. The first way is using index. Okay. Then there is another issue when we are using the relation. So this is nice. It keeps all the information database about the university. So how many users? Sometimes you have one user, but usually many users would like to access the same data. So you can give the database copy for each people, but it's very hard to manage, right? Somebody manage well, somebody update the data, but the others are not. So we'd better have the one centralized database. The problem is it's a big and multiple user. So how can we support concurrent access to the data? So we have discussed about the transaction concept and theory the last class. Okay? And there are many, many other issues actually in relational database management system, but we discussed in this class So in this semester, several important concepts. Okay, so today we are going to discuss about the concurrency control as one of the issues in DBMS system. Okay. What is a concurrency? What does it mean, concurrency? Concurrency. What is a concurrency? First, you need to understand the concurrency. Yes. Same time, you wanna access the data. You do not have the multiple copy of the database. If you have multiple copy of the database, that's a waste of space. Also, it's very hard to manage. Right? As we discussed before many times. So we have one copy of the data, shared data. It should be shared by, as we discussed last class, it's a multiple transaction, multiple user. So it's okay. You allow many users to access the data, but how can we keep the consistency? Consistency is a state, same state, for the same situation, same condition, same data for all the user. Concept. By keeping such a consistent, how you can support concurrently access the database. That is a concurrency control technique, which is much related to the transaction issue. So, however, if your database is only read-only, do you need to worry about such a concurrency control?
Yeah.
No, you can just allow, no matter how many users, how many transactions or requests to access the data, you can allow because it's just read only. There is no change, there is no problem in terms of the inconsistency. Just allow as many users, as many transactions as possible. However, when you allow the writing, there are two main operations in database. One is a read, another one is a writing. Writing causes such a concurrency problem, as we have took a look at very briefly last class, but this class we will formally define such a concurrency problem. Then we'll see how to solve such a concurrency problem. Okay. The concurrency problem will be happen when there exists conflict. Let's go back to whenever we have the new problem, we go back to operating system, right? I cannot still remember who are taking the operating system. Probably. Which chapter are you learning in the operating system right now? So you are taking the operating system, right? So in file system, did you learn the transaction? Right? So do you learn the race condition? Right? What is a race condition?
More than one process accessing
the same memory between the shared data, right? Then, did you learn about the conflict? So what is a conflict? When is a conflict situation? So, for example, I will give the example. So I have the shared data, not in the memory. In this case, the shared data, okay? But we have the two transactions, two users try to access this data. Then they try to only read the data. Is it conflict or not? No, there's no conflict in such a case. Also, another example is, so we have the shared data, but there is only one user, one transaction. That transaction read, write, everything. Is it conflict or not? No, there's no conflict. You can allow. When you have one user, one transaction, you can allow whatever they want. You can allow. There's no conflict. So then, what will be the conflict? Conflict means when you have multiple transaction, multiple user, okay? Then they try to fight to update the data. If there exists writing, at least one of the user try to access the data for writing, that will cause the conflict. So there are three conditions. So they multiple transaction, they belong to different transaction. It's a different user, multiple user, right? And second, they access the same data item X. Okay. The last one is at least one of the operation write the data. Then that is called conflict. So write data item X. So for example, R1 means transaction 1 read the data X. Okay. This means transaction 2 write the data item on X. Okay. Okay. Is it conflict or not? Two transactions and same data and there exists one writing, so it's a conflict. That may cause the concurrency problem. So we need to address such a problem. Maybe. What about this one? Two transactions, 1 and 2, right? There exists a writing, it's the same data, it's a complete. What about this one? Why this is not complete? It's only read. No matter how many users want access the data, yes, it's just a read. What about this one? It's a two transaction and writing. Is it conflict? No, they access different data. They don't care each other. So it's not conflict. This time there's no problem on concurrency. So this one?
Same user.
It's the same transaction, it's the same user. You cannot update, delete, read the data, no matter how many data you access, it's totally fine. So in case there exists conflict, we need to address the problem. What if we do not care about such a conflict case? That will cause the problem of, can you remember the last class? 3 problem, update, some temporary access. So you cannot guarantee the data because the data will be changed in the middle because of the race condition. Okay? So we need to take care of such a conflict case to provide the consistency of the database. Okay? So how to address that problem using a lock. What is a lock? Actually, the office door has the problem on the lock, so I cannot sometimes open the door. So I need to little bit here the handle, then I can open it. If my door is locked, nobody can access my door. So it's isolated. I can do whatever I do. I can take a nap. Okay, nobody cares. Nobody knows Professor Lee is sleeping or not. So when door is locked, it's only for me. It's a private. Okay, cannot be shared. There is no sharing. There is no conflict, right? So locking is one of the easy way, best way to address such a problem. How can we lock the data item? We can lock the door, so we can keep the isolated area. How can we lock the data? You prohibit the other process to accessing the data, right? So in other words, you do not give the permission to access such a data item that is locked. In other words, only me can access such a data until unlock the data. Okay? Then everything will be solved? No, not yet. Why? Locking mechanism can solve such a conflict problem. However, that will cause another issue. What if I keep the lock forever without unlock? The other transaction, the other user should wait until I release the lock. Entire system hang sometimes. It's a stop. Okay? Also, it's a very expensive operation, such a locking, because you need to keep log such an activity. So we need to consider such a performance and the concurrency issue. So we are going to consider two-phase locking technique. Two-phase locking means there is just two steps. One is getting the lock. Another one is release the lock. It's a simple idea. So getting the lock and release the lock. Okay, so we will see in details about it. So that is the two-phase locking technique. So locking operation is what about the read? When I lock the data item, this one, can it be read by other transaction? If depending on the type of lock. You can lock the item for read, which means even the other transaction cannot read the data. That's called the read lock. And write lock means the other process can read the data but cannot write the data. So there are two types of lock. One is the read lock, another one is the write lock. So locking means they give the permission to read and permission to write, but the other transaction cannot read the data, cannot write the data. Sometimes you can allow to read the data depending on the lock time. So there is a operation lock. So lock of X means the X is locked for that transaction. Unlock is the release all the resource. So two-phase lock. Two lock means there are two types of lock. One is a read lock and another one is a write lock. So read lock is a shared lock. You share the data item but cannot be updated, cannot be written. Why the exclusive lock is the write lock? So that means the other user, the other transaction can read the data but cannot write the data. Okay? So sometimes it's called the shared lock for the read lock, and the exclusive lock is the write lock. What about the operating system? So file system has the read lock, shared lock, or the exclusive lock?
Right. Shared.
I got confused more than one transaction can apply shared lock. Shared lock means I think the explanation is wrong. It's a little bit confused. Shared lock means you can get the shared lock whenever you want. Okay, for read only. You cannot get the write permission. Okay? Why? Exclusive lock means you can get the lock on this item for read and write. That means how many transaction can get the exclusive lock? Only one. What about the shared lock? It's a many user can get the shared lock. Okay? I got confused. So it's a different perspective. Not for data item, but for transaction. For each transaction, how many shared lock means many transactions can get the shared lock. Okay? Because it's only for read. But the exclusive lock is allow read and writing. Then how many transactions? Only one transaction get exclusive lock. What about the other transaction who want to get the exclusive lock? Not, it can be read only, but mostly wait until data item X is released. Okay? In other words, the transaction released this item is unlocked this item. Okay? That is the exclusive lock. What about the file system? It's a shared lock. You cannot write at the same time. You cannot get the exclusive lock same time. For example, you open the MS Word file. Can you overwrite you can open the first time and second time for the same file, right? Second file will be read only, which means you can get the shared log. You can read the data, same file, but you cannot write the data. The first one, the word file will first the transaction, first window can override or write, save the data. Otherwise, if you want to save the file which is already locked by other window, you need to save as different name, right? So that is a shared lock. So to implement the two-phase locking is the first phase is first get the lock that you want. If you want to read the data item only, at the time you can get the shared lock. If you want to write the data, you need to get the exclusive lock. Then, if you finish the writing or if you finish the reading, you need to release the lock. So that is the two-phase locking. So to implement this one, you need to have the lock manager who is in charge of such a locking. Okay, like the buffer manager who are managing the memory, shared memory. So the database should have the lock manager. What? Actually, what is it? The lock manager. When you implement the DBMS system, what will be the lock manager? It's kind of process. Okay, it will be processed. It's a component part. It will be processed to organize this one. So lock manager keep track of this information. Basically, the transaction ID and data item and the lock type and the next the pointer to the next data item. So this is called the lock table. Each DBMS manages such a lock information. Okay. So when you process any data item, like the read, write, you need to get the lock first. That is the basic operation of the lock manager. So I'd like to read the student data. Select select the name from the student where ID is 111. At that time, you need to get the lock from the lock manager. Okay. Select is just read only. So at that time, you need to get the shared lock. Okay. However, if you try to update the data, update the name, or update the student, set name is the new name, where ID is 111, at that time you need to get the exclusive lock from lock manager. So lock manager is in charge of such a thing. Provide the permission, give the permission, or the organizing such a lock to keep the consistency. Okay. If you want to implement such a lock operation, this is the pseudocode, very, very high level pseudocode. So for example, lock data item X is the, in case of lock, we will set the 1, the Y, the 0 means it's unlock the data. Okay. In case of unlock, you can assign the 0, so other transaction can access the data. Okay. Read lock, you need to manage how many users are accessing the data at the same time. That is the number of read. The data item X. It will be increase, plus 1. Okay. If there is no other, if the number of read is 0, it will be unlocked. Okay. And write lock, only one user can access the data, so you don't have to manage the number of read. So instead, just assign the write lock, and otherwise it's unlocked. In case of the unlocked data item X, so it will be set to 0. And so in case of read lock, you can reduce and until 0. In case of 0, it's unlocked. Write lock, only 0 or 1, so you can unlock. There's a lock conversion. Lock conversion means sometimes first there's a transaction that read the data, select student name, okay, from the student. Then next, you update or delete the insert the data, write the data. At that time, first lock is shared lock, but it is converted to the write lock. So lock will be promoted. It's called the lock conversion. Sometimes you can upgrade the lock, or sometimes it can be downgrade. So you update the data, but no more updating, no more the writing the data. At the time, it can be read, the downgrade, upgrading and downgrading, promoting or downgrading the lock. So finally, the two pages is locking and unlocking, growing and shrinking. This is the most popular. Actually, the Windows, the operating system uses such a technique, even though you do not realize the name of two-page locking. Two-page locking is one of the popular approach algorithm. Okay. So this is an example of the two-page locking. So we have the two transactions without considering the consistency. So for example, transaction 1 read the data item 1 and read lock. Before you read the data item, you need to get the lock. That is a two-page locking. Okay. Whenever you read the data or whenever you write the data, you need to get the lock, appropriate lock from the lock manager. So unlock Y and to write the write lock from or X, read the data item X and update the data X and write and so on. So transaction 2 has the similar, but first read the data read lock for S, X and read data item X and unlock X, then write the lock on Y and update the Y and unlock Y. In that case, it's the same problem as the race condition. So as you can see, the initial value, for example, 20 for X and 30 for Y. So in this case, so T1, for example, if the first T1 is done, then T2 is the next. Okay, then Y is 30, T1, then read the data and then X plus Y plus 20 is a 50, so X will be 50, right? And then Y will be read data item X, that is the 50, then plus Y is 30, so Y will be 80, that is this one. Then if T2 followed by T1, T2 is the first, T1 is the next, T2 is the first the X is 20, okay, then add 30, it will be 50, okay, no. T2, so read X is, then followed T2 from. X is a 50. X is 7, 20. Oh, I see. So, if we do not consider the transaction, which means first read log, okay, T1 followed by T2. This one, this one, this one, this one, this one, this one. That may result that one. Or if you read the date, execute the T2 first, this one and this one, then it will show the different value. So this is the initial value is 20, 30, result to 0 execution, T1 followed by T2. Yes, that will be 80 and 80. Then result of 0 execution, T2 followed by T1. So 50. X is 20. Read log, no. Oh, I see. First one is correct. So first one, at first we learn the T1, then next the T2, because that is the log by the transaction. Okay, so T1 get all the log, then run it, and then followed by T2. Then we will get the x equal to 50 and y equal to 80. What if we learn the T2 first? So that means the x is 20, then added by y, so it will be y. So y is 50. Then with 50, then add 20x, it will be 70. As you can see, depending on the order of transition, the output is different. Okay? So, if we consider two-phase locking, so it will be based on the log. Okay? So, this is the algorithm. First, T1 get the lead log. So, it will be 20, 30, right? So y equals 30, x equals 20. So lead log, so it's until unlock is 30. Okay? Then T2 can get the read log because it's a serially process. So then x is 20, right? And unlock x. Then write log on y. Only transaction 2 get the log to update this one. And even though this time it will get the log on y, it's fine because it's a read log. Then write log and read the data item y, then y plus x is 50, right? Then unlock. Then this time write log, it will get the write log on x is 20, it will update on the other process transaction. Then read the data item x20, then add it by the y. Y is actually, in this transaction, is 30, right? Because it's in the same transaction. It will not be changing. So we'll add 30, so x will be 50. That's we expected. That's different from this. Does not consider two-phase locking, okay? But if we consider two-phase locking, so whenever we read or whenever we update the data, then we need to get the log of data item so we can keep the concurrency. Okay? There are two types of the locking algorithm when we implement the two-phase locking. One is conservative, another one is the basic. Basic is conservative is conservative, which means we got all the log that we need to access in the same transaction. For example, in previous example, in this case, transaction 1 need to get the log of read log of y and write log of x. Then you can start the transaction. In this case, T2 can be started when all the data log is acquired, like the read log on x, write log on y. Then you can start the transaction. That is conservative. The basic is you can get the log whenever you need. So incrementally, you can get the log. You can start the transaction. So while you are processing the operation, if needed, you will get the log. Otherwise, you will be stuck. Wait for the item. Okay. in terms of deadlock, which one is better? Conservative. Definitely you will not get any problem, deadlock problem in this case, because you need to check, you need to get all the lock on any data item, then you need to access or modify in the same transaction. Then you can start. So there might be no problem. However, basic, you need to process until you, whenever you need the lock, you need to wait until the item data is available. So sometimes it can be deadlock situation. Okay. 3 version is the 3 is the based on the basic. It's the incrementally you can acquire the lock, but so there exists conflict situation. You need to solve that problem. That is the 3, the version of the 2-page locking. Basic is you can just proceed. Okay? Then if there's a locking, you just wait. However, strict, you can process, but in case of conflict, if there is a problem, there is a lock, you need to solve that problem. So there are several types of solution for strict. Okay? First one is wait time, and another one is und wait, which means depending on the timestamp. Timestamp is the when the transaction is a time, when the transaction is started. It's a starting time of the transaction. Which one is older, which one is younger, you need to check. So either of them will be die, which means killed. Another one will be acquire the lock. Then we can solve the problem. Why? Because of the deadlock situation and solution. So everybody knows the deadlock. Deadlock is process A, process B, data item X, data item Y, and wait another. If we generalize such a problem, it will be kind of circle in wait for graph. Can you remember that graph? Am I right? It's a wait for graph. Like this one. This is a process, and this is the item. I think the item. This is a process. So it's the request, right? Can I remember the exact name? So wait for graph. I think the wait for graph. If you can find such a circular fashion, it will be deadlock. Is it the wait for graph? Can you remember that? In the deadlock? It's a wait for graph, right? In the wait for graph, if you can find a circle, that will be deadlock situation in general case. So, in case of deadlock, what will be the solution? There are 4 solutions. Can you remember that? What is the solution? It will be your final exam, right? One is deadlock prevention. Second, deadlock avoidance. Third, deadlock detection. One is detection, the third one is, first one is prevention. Prevention means, first, if any evidence that caused the deadlock, you will not start the transaction. That is the prevention, right? So there might be no problem, even you do not start. Okay? In other words, until you get the whole the data item, the permission, then you can start. Right? So that may not cause never ever deadlock situation. That is a deadlock prevention. It's a perfect to avoid the deadlock, but problem is sometimes it takes a long time, forever. It's a starvation. Another one is deadlock avoidance. Avoidance means a detection. So you proceed, start the transaction, but if you detect the deadlock situation, like the cyclic graph in wait for graph, okay? then you resolve that problem. You need to detect the deadlock, then resolve it. There are several ways of the solution to resolve the deadlock problem, like the backup or the preemption, or there are several ways, but we will not discuss details about it anyway. So there is it's a way for that, right? So it's a detection. What is a deadlock avoidance? Deadlock detection is already happened, deadlock, right? So you detect and resolve that problem. Deadlock avoidance is for each operation, you need to check whether there exists a circle or not. So if there is a chance to make the circle in wait for graph, you will not enter, or you need to resolve that problem. It's avoid. So prevention is never enter such a situation. Detection is you allow to